Module 6, Lesson 7, Fraction times Fraction. This operation is really interesting because it's like division times division, and we learned about how multiplication and division are opposites. When we get to multiplying fractions times fractions, that's where all of this stuff really gets interesting. A lot of things start to come together. Our understanding of what multiplication and division mean, our ability to do area models, and multiplying fractions by each other is one of the tougher core concepts that we'll encounter in elementary school, but part of what's cool is there's a really powerful and simple algorithm. But I don't believe we should be using algorithms unless we know how they work, and visual models will show us how this algorithm works. So let's give it a try. So 1/2 is probably our most basic fraction, and so it's a great place to start is to do 1/2 times 1/2. And what I've done is I've colored in half of this circle in green. That's my 1/2. Then I took 1/2 of 1/2. So one of the tricks to multiplying fractions is to begin thinking about this as of. So we learned 3 groups of 2 or 3 groups of 6. Well, this is 1/2 of a group of 1/2, or 1/2 of 1/2. One thing that happens is that instead of being cut into just 2 pieces, now it's cut into 4. And we're going to count the piece that is shaded in both, right? So if this is 1/2 of 1, or 1/2, which is what we're starting with, and we're taking 1/2 of that, the area representing 1/2 of 1/2 is that amount. So notice it's smaller than the original. This is one of the principles of multiplying by a number smaller than 1. When we multiply by 3 or 5 or 10, any number larger than 1, we get something bigger. But when we multiply by something smaller than 1, we get something smaller, right? And that we can connect to the identity principle. If we multiply by 1, we get the same thing. So that's another way to logically start creating those connections. Oh, it makes sense that 1/2 by 1/2 is smaller than, not only smaller than 1, but smaller than what we started with. So we started with 1/2, we multiplied it by 1/2, and visually, we should be able to see by now that this is 1/4, right? The question is, how do we get there? Why does 1/2 by 1/2 equal 1/4? And can we generalize that to apply it to other fractions? So to look at another example, here I'm going to use a rectangle, and it's going to get easier as we start doing some more complex operations. In general, the rectangles are going to be a little more flexible than the circles. So for this example, we're starting with 1/3. So I've cut this into 3 pieces, and I'm going to multiply it by 1/3. So in order to multiply by 1/3, or take 1/3 of it, 1/3 of 1/3, I'm going to cut in the other direction. And now, before I do any shading, let's just look at our cuts. I started with one hole cut into 3 pieces, and then now I've cut it the other way, right? So each of these 3 pieces now turned into 3 pieces. So what I actually did was I multiplied my denominator by 3. So if I multiply 1/3 by 1/3, don't yet know what my numerator is, but I've cut it so that it's now in 9 pieces, right? 3 times 3 is 9. So that's pretty, I feel like that's pretty interesting and pretty cool, that to multiply a fraction by a fraction, at least for this one step, I just multiply the bottom by the bottom. We can't do that with adding fractions. Can't just add the bottoms together. But with multiplying, we can. So 1/3 of 1/3, I've cut it into 9 pieces. Now let's show the 1/3 part. So here in blue, we have the 1/3 going this way. Well, now we're going to have 1/3 going this way. And again, I'm going to look for the overlap. Here, I now have one piece that is colored both in blue and green out of 9 pieces altogether. So 1/3 times 1/3 is 1/9. Now, we haven't quite generalized that yet, but let's step back just a second. So now instead of just limiting myself to unit fractions like 1/3 times 1/3, I've done 1/3 times 2/3. So now my green fills up 2/3 of the total. We still have 9 pieces, right? We're thinking about this brick as 1 hole by 1 hole, right? So each of these represents 1/9 of the whole. But before, where we had one box that was shaded in both blue and green, now because of our 2, we have 2 of them. And this gives us a hint into how do we find our numerator? Well, we multiply 1, because that's how many we have going this way, by 2, which is how many we have going that way. That gives us our numerator, which is 2. And then our denominator, we're looking at the total. And again, it's 3 this way by 3 that way, so that's 9. So in a pretty cool way, this brings together almost everything we've studied in our K-3. We're using our area models. This is kind of like arrays because we're counting up our total number of boxes. We're thinking about the meaning of multiplication. And this is still a relatively simple example, 1/3 times 2/3. Just to show how powerful this algorithm is for multiplying, let's look at a number that's even more complicated, multiplying fractions that don't really have anything in common with each other, and see if we can still use this model and still use that algorithm. So for this example, I've cut this rectangle into 8 even pieces, colored in 3 of them. So I'm starting with 3/8. And let's say I want to multiply this 3/8 by 2/5. First thing I need to do is cut it 5 times this way. So if I have 8 cuts going this way, 5 going this way, well, that's the same as having an array. That's 8 by 5. That tells me the number of pieces altogether. How many pieces have I cut my whole into? 40. Now, because I'm multiplying by 2/5, let's shade in 2 of those strips. Now my total is going to be the part that's covered in both blue and red. That's going to give me my numerator. And since it's 3 across this way and 2 down that way, it's going to be 6. So we can use this visual model to confirm that our algorithm for multiplying fractions, in fact, does work. I'm multiplying 3 by 2 to get my numerator. I'm multiplying 8 by 5 to get my denominator.